Start recording. Okay. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. No engines, no libraries. It is just us and looking at the complete process of game development, right from the little tiniest little pixels that make up our game screen to the AI that controls the characters or anything in between. We show how to do it. And right now, we're at a crossroads in some sense. Just yesterday, we finished our asset pack files, and they're pretty darn cool. The stuff that we engineered for them, I think, is pretty darn neat, considering we didn't take very long to make them, and they're awfully powerful at this point. So I'm kind of psyched about that. And there's really two things we could do. Like I said yesterday, one thing that we can do now, actually, I guess there's three things we could do even. The first thing we could do is go back over the asset pack file stuff and just take a look if there's any features we want to add, any little things that we think we might want to do differently, or we had talked about some things like adding the ability to suppress assets from other pack files. So like if you want to patch or do things like this, we could go do that. The other thing that we could do is we could move on to working on the asset memory management. But there's always the third thing, which is like we've got 2 days left in the week, Thursday and Friday, and so the asset memory management is going to be a pretty big deal. That's going to be a hard thing for us to do because it's the hardest memory management we'll have to do in the entire project. It's a virtual memory system, basically, because we want to have a system that will optimally, well, not optimally, that's probably provably impossible, but that will very efficiently manage a certain prescribed footprint for art asset data, and it will cycle through the art assets for the game through that system based on what the most necessary things are for any given scene in the game, right? So it'll kind of be trying to think about what needs to be brought in and what needs to be done. And that's going to be, I think, one of the more tweaky things that we do on Handmade Hero, where it's going to be kind of a little bit finicky. And so, that might be a better thing to start on Monday and just do, this week we're going to start on that rather than doing a Thursday, Friday thing, and then jumping the weekend, right? So the other thing we could do, third thing we could do, is something else. And so what I'm going to do here, again, I'll briefly mention if we do coding today, which we probably will do some coding today. I don't have anything planned for the Blackboard that would take an hour. Day 155 is the day that we are on. So if you pre-ordered the game on handmadehero.org and want to download the source code that goes with what we're doing today, download day 154's source code. That's the source code from yesterday, and that's what I'll be starting with today. So what you want to do is start out with that, and you will be right exactly where I am when I start now. And what am I going to start doing? Well, I am going to go look at that to-do list to see if there's anything else that we might want to pick out that's a 2-day thing or something like this that we might, that might be something we should do instead of, instead of what we're doing before. So, hey, guess what? We did this, so that's all gone, right? We actually did these as well, kind of. I mean, I think we really just pretty much did all of this, so we kind of just have these left there. We could go fix some audio bugs. We have this sort of, on the reload system, we wanted to flush thread queues before reloading the DLL to avoid any crashes that might happen. I don't actually know, we haven't ever actually had one, so it might not be a problem, because it's not something that'll ever happen in the shipping game, so unless we're having trouble in development, we don't really need to care. And so the question is, like, is there anything else you might want to do? We haven't done fonts. I don't know if that's a 2-day thing. It might be a little bit more than a 2-day thing if I want to walk you through the whole process. And so I feel like debug code wants to wait for that. So in our architecture exploration, we've got metagame, save game stuff. These are sort of things that we will start on, I think, in kind of going with the game itself. So I don't know. Let's think about this for a second. So I guess what I would say is, I guess what I would say about these is, we could just do something fun for 2 days, just for no apparent reason. So maybe we just do something maybe we can just pick something that's going to be kind of fun for 2 days, something kind of weird. I don't see anything particularly obvious, but the one that kind of jumps out at me here would be, what about this guy, right? Particle systems are pretty darn simple. at the end of the day, and that might be a kind of interesting thing just because there was something, you notice I've got it up here on the renderer. It might be interesting to have that in place because I think they might slow down the renderer a lot, and it might be interesting to see how much they slow it down and to see if we want to put them into the renderer in a more specific way, just so we can play around with that a little bit. So maybe we'll do particle systems. I don't know. That seems like kind of a fun thing. I don't know. What do you guys think? Particle systems? Maybe we'll try that. Let's just play with that for 2 days, and then we'll start on the asset memory management stuff tomorrow. So let's take a look here at what what I would do for particle systems. Okay, I'll do a brief kind of diagram on the blackboard. We'll get Mischief up and running here. Blackboard.art, and I will. Oh, did I do? Well, no, it's just kind of loading, I think. Come on, Mischief, you can do it. You can do it. I know we're asking it to do a lot. Our Handmade Hero blackboard is so massive now. It just kind of goes and goes and goes and goes ad infinitum. This is why I usually leave it running, but of course I had to reboot the machine recently to do the Microsoft Windows update to fix that lovely thing they have where people can root your machine. All right, so let's talk about particle systems briefly, just so you can have a little bit of a perspective on what these things are. So particle systems. And, if you think about how game graphics works in general, we've got sort of a few different buckets that we put things into depending on what it is that we are trying to draw. Okay? And so in a 2D game, for example, you've kind of already seen actually 2 of these buckets that I have implemented already in the course of building the Handmade Hero engine as things that I know that we will want. And so we built them in, and I showed how to do them and that sort of thing. And remember what they were is ground tiles, right, are the things, and sprites, right? And so if you remember, we did these in kind of different ways. They both flow through the same renderer, but like when we did the ground tiles, right, what we did is we broke the world up into like these tiles, right, and we made sure that they would, be seamless, so then when we drew things in them, it would work or whatever, and things would be continuous across the lines. But we fundamentally thought of them as like a grid where we would paint into the grid, and as things came on the screen, we would, draw the new tile to put it on the screen and so on. And we had to think about it that way as opposed to about a bunch of sprites, because fundamentally speaking, the actual graphic that we were trying to represent is a whole world worth of non-repeating texture, right? It's this gigantic, infinitely stretching thing that represents the ground, and I didn't want it to repeat. I didn't want it to be some cheesy tiled grass thing or whatever, right? I wanted it to be unique everywhere, and I wanted it to be able to us to do any kind of special effects we wanted in there, like drawing in footprints or drawing in like a river or anything like that. And so fundamentally speaking, what we basically made here was like a giant virtual canvas, and we draw into the giant virtual canvas and only fill in the parts that you can see on the screen, because generating the whole thing would be completely impractical. So that was kind of one thing that we did. And the other thing that we did was sprites, which are just, the standard things that we make little characters up out of. We'll take a head sprite and a body sprite and a torso sprite, right? They're rectangles that we put little bitmaps in that have an alpha channel. And that's, what makes up our little guys, right? So, when we run the game and we have our stuff in here, right, we've got kind of this little dude, and he's made up of 3 pieces, and then we have some other stuff there and little test things, and we've got the ground textures and of course our trees, that sort of stuff. And sprites are a very good tool, right, to build up a 3D game. They can express a lot of things to the player, and they're a good way for us to take art assets that an artist can paint and put them in, bring them alive, right? And so they're one of the oldest and most sort of they're a real workhorse of a 2D game, right? And sometimes even in 3D games you'll see them, but in 2D games they're the bread and butter, right? So we have those 2 things, but there's another thing, right? That kind of happens, which is that sometimes we have things that don't have a specific shape, right? Sometimes we have and maybe the word we would use for these are phenomenon, right? Right, like things like liquids, right? Oops, wow, spelling, illiteracy, ladies and gentlemen. Liquids, gases, mist, right? Things like this. And these sort of amorphous shapes are very difficult to describe in terms of the things that I'm talking about, because an artist can't really draw the shape of a free-flowing mist, like a mist that kind of swirls around on the ground, or it doesn't really make sense. It has to react to things, and it's kind of this continuous shape that deforms in weird ways, and there aren't really pieces to it, right? And we've got other things like, smoke trails, right, or this sort of thing. Explosions, very common in shooty kinds of games. You've got just a whole bunch of things that these sort of natural, sort of amorphous phenomenon. And they are just not that amenable to tackling with either of the two things that we built so far. So what you typically want to do for these sorts of things is that's where you use a particle system, right? And a particle system, need to go back to grade school here, clearly, to practice my handwriting. A particle system is exactly what its name sort of suggests that it is. It is a series of little particles that are treated together to form a system, and the system itself is supposed to represent one of these bigger phenomena. So, for example, if we did want to make a trail of smoke, or a fire, or whatever else, what we might do is create a particle system to capture the sort of feel of a fire. And that is how we would solve that problem in game development. And there's levels of complexity of these particle systems and a lot of other things we could talk about. I'll mention some of them briefly, but I'll simply say the basic idea behind it. So what you typically see in a particle system on the effects house side of particle systems, so these are the kind of effects you might see in a Hollywood movie kind of particle system, and also in a game that's being kind of authored in some sense. Typically what you have in a particle system is you have a thing called an emitter, right? And as its name implies, it is some kind of a shape on the screen whose job it is to emit particles, right? So let's say we're making a fire. So we've got some log sprites or something on the ground, and we want there to be a fire that comes up from those log sprites. So we place a emitter for our fire particles onto this place on the logs, right? And that emitter typically has some things like parameters, like what shape it is, where do the particles start. It has a bunch of parameters for how the particles behave, right? But the basic idea is that it's going to take this shape and it's going to put little points, right? It's going to spawn little points at the location inside that shape, right? And again, particle system basically means these are particles. They're little points. They're little points in space, right? Then what's going to happen is as these are spawned, they are going to have some kind of simplistic simulation to follow. So what they might do, for example, is be told that they should kind of have a random direction within some upward facing cone, and they will kind of flow out in that direction. They will kind of come up, and as they come up, maybe they'll wobble or something like this, and as they get taller, they will go from being, maybe down here. When we want to render them, we'll do one thing, and when they get up here to render them, we'll do something else. And that kind of gets into the second step, which is we have these particles. They're going to start down here. They're going to move, right? They're going to be simulated up. New ones will spawn, and those will move. And so you kind of end up with this kind of upward motion particle kind of thing, right? And then what you do is you have these points, right, in your particle system. And what you do is you end up on any given frame having a bunch of locations where all the particles are, right, after you have updated them, after you have simulated them forwards. And at that point, what you will do to render them is you'll typically do something that involves putting down sort of a fuzzy, blurry kind of a shape down over the top of them that may be like kind of dark in the middle but get kind of weak towards the edges, right? And the idea behind that is they kind of form this kind of blobby, kind of amorphous shape by sort of, being dark in the middle and sort of amorphous at the edges. So you get kind of this shifty sort of, again, like fire, gaseous, or liquid kind of effect happening by the fact that the way that you're filling it in kind of blends the shapes together, and there's no like hard edged outline of what the shapes actually are, right? So that is what a particle system is, right? And it's pretty simple to think about if you've followed Handmade Hero so far. It's actually not very difficult to think about what a particle system might entail implementation-wise, because when you think about it, really all of these things are fairly obvious how we implement them. They're things that we've already done in a lot of ways, right? all we need is some list of particles, like some way of tracking what the particles are, and we just need to make a for-i loop or something that goes over each particle every frame and simulates it forward. And we've done the equations of motion on Handmade Hero. You know a little bit about that. There's really not much more to it for updating the particles. So really the only thing that's a little wonky is how we would actually render it. And to start out, we could certainly just shove it down the same pipeline that we've been using by basically taking a sprite, that is sort of a filled blobby circle like that, and just rendering one of those sprites at the location that is indicated by the particle. So what I want to do to kind of get you warmed up to particle systems, I'm looking at the clock here, it's 5:25. We started like about 15 minutes late. We're only 10 minutes into the stream. So we've got a good 15 minutes to go here. We'll go to about 6:15 to get our hour in. So in 50 minutes should be plenty of time for me to kind of get you a little warmed up to the idea of these particle systems. Just take a look at what the code looks like at a very simplistic level. And we won't try to make anything fancy today, but we will try at the end of that 50 minutes to get to a place where you can kind of see the particle system operating. So what I'm going to do, again, and we say this very often on Handmade Hero, I like to say it very, very often, don't overthink it. You just want to make the simplest thing first. Right now, like especially out there, you've never seen a particle system before. Don't go overthinking it. Just go, what is the bare minimum thing I would need to do to get something on the screen? That's what you focus on, and then we build from there, right? We always build from there, and you've seen me do it many times on stream. We start with something simple. We start with something we understand, and then it becomes very clear to us through the crafting of that how it needs to start integrating up and becoming a more general component of Handmade Hero's engine as a whole, right? And so don't overthink it. Just go exactly what I just said in the stream. That's exactly, on the blackboard, that's exactly what we want to do. Let's just do that in the simplest possible way first, and then we will start to generalize out from there and generalize out from there, right? So, okay. So let's start just by saying, I've got our game state here, and I'm just going to straight up say that I'm going to want these particle systems, right? So I'm just going to want, a particle, right? And I just want to track that list of particles, right? I said I want a group of particles. I'm just going to say flat out, you know what? We've just got some particles here. How many particles do we have? I have no idea. Let's say we have 64 particles because that's how many I'm feeling like doing. Again, just literally just the simplest possible thing to get things started. And I will say that there's a next particle or something like this, right? All right, and so in our particle, we're going to need a couple things. Obviously, like I said, we need a position. We need a location where the particle is. We need maybe a velocity for the particle, so that's how fast it should be going. And maybe I also want something like a color for the particle so that we know what color we want the particle to be. And, like I said, I don't want to get too overcomplicated first, so that may be fine. That will allow us to place some particles down and watch them do something on the screen, which is all we really want to do for today to get warmed up, okay? So let's go ahead and do that. Let's go in here to our game update and render. And again, this is kind of game update and render is the main loop for the game, and it's kind of our home for misfit toys, right? It's the place that everything lives right now that hasn't matured to the point where it breaks off into its own sort of like self-contained thing, right? So we still have like our entity code and stuff in here because we haven't really gotten to that and that sort of stuff, and we have our ground chunk stuff in here because we haven't really decided how those will be doing, their final thing. We did all the composite work and stuff like that, but we haven't actually gone and said, oh, how does the world, generation integrate with this? Because until we have our sort of our game running and generating worlds for the player to explore, we don't really know how we want to do our ground chunks. And so what I'm going to do is I'm just going to pick a place here. I'm just going to go down to the bottom where we have generally appended like our test code. And you can see right here is where our renderer updates. So just right before the renderer updates, I'm just going to go ahead and say particle system test, right? That's all I'm going to do. And so what I want to do here, oh, you know what? I forgot one other thing. And I guess I'll tell you, well, you know what? I don't really have to do that yet. I can just show you why we need it as it comes up. So what I want to do here is I want to loop through all the particles. Okay, I just want to loop through all the particles. So what I'm going to do is I'm going to start at the first particle. I'm going to go to the end of the particle count, right? Here's that array. So I'm just going to say I want to go till the end of that. And then I want to go ahead and increment that particle index. And so I'm just going to loop through the particles. Again, absolutely nothing fancy here. I'm not thinking about speed, not thinking about any of the things that we might think about eventually when we go to say we want this process to be fast or capable or whatever. Nope. Just thinking very, very basic, keeping it very simple. So I'm going to loop through the particles, and on each particle, what I would like to do is first I would like to simulate the particle, right? So I want to do simulate the particle forward in time, right? And then I also want to render the particle. And I have two choices. One thing I can do is I can render the particle and then simulate it. The other thing I do is simulate the particle and then render it, right? And the consequences of the two of those is if I simulate it after I render it, it means that the results will not be displayed till next frame. And so it has some benefits when you do that. It means that when particles are spawned, they are drawn at the location they are spawned rather than being simulated right away to a new one. But it has some downsides, which is that you won't react to user motion that happened on that frame until the next frame, right? So what I'm going to do is I'm going to simulate first, and then I'm going to render second to avoid that problem. And we'll deal with the fact that things move when they are spawned. We'll deal with that maybe in a different way, or we'll try to address that in some other way, right? So now I want to do render the particle. Now rendering particles, like I said, doesn't really seem like something that will be very difficult. If we just want to do a simple test case, what I can do is I can take this sort of draw bitmap call, right, where we call into the renderer. And what I can do is I can just use our existing renderer to draw our particles for us without really having to do anything, any other work, right? So what I'm going to do here is I'm going to, again, leverage that call. We can take a look at what that call does, right? You can see draw bitmap. And all we want to do is pass our particle bitmap. So what I'd like to do is make sort of a test bitmap. So we'll just call it test particle, right? And we'll put that in the game state for now. And then I need to pass it, oh, whoops, sorry, that's the buffer. Ooh, my bad. Don't want to draw to the test particle. I want to draw to the actual render output. So that's a little bit of a mistake there. Sorry, cut and pasted from a bad location. What I actually want to do is just draw to our standard render group. That was all. This is old code. This is old code. What can I say? Yeah. There's a reason it's all if zeroed out. We could probably get rid of it, but we may want it again when we do the lighting test. So my bad. Sorry. You know how it happens sometimes. So we want to push a bitmap out to our render group, say, here, we're going to draw this thing. We're going to draw a test particle. And then we need to say like how high that, how big we want that test particle to be. I don't think we want it to be very big. These are supposed to be like little small particles. We'll tune that later, so it doesn't really matter. But, just pick something. 1/10 of a meter is what I picked there, 0.1. All of our units are going to be in meters, I believe, there. So that's roughly what that should be. Then we have the offset. And the offset is just the offset from the placement of this particle, which I don't think we really need to have at all. So I'm just going to say you don't really need to offset it. And then we're going to have the color, right? And so I don't actually remember, although now that I think about it, the offset is actually the only thing that we use for positioning now. So actually, I guess technically that positioning is possibly going to be actually, yeah, that might actually be the full position, because we probably won't need to use the transform. We wouldn't want to use the whole transform system for every individual particle, and we'll see kind of why later. So maybe that was the wrong thing to say there. I think maybe the easiest thing to do would be let's actually pass that position. So we know that the particle itself does have a position, so we'll go ahead and pass that position down. And then we know that the particle, like I said, also has a color. So we'll go ahead and pass the color to it as well. And that is how we would render a particle, right? And so let's go ahead. Oops, little typo there. Got to access that off game state. And so now what we need to do is we need to find a way to make this test particle. And if you remember correctly, we actually have a way of drawing a sphere. I believe we had some kind of a test sphere thing that we were using for our normal maps. I think make sphere diffuse map, right? And so what I'm interested to know is, can our make sphere diffuse map thing, in fact, do we even already have one? Might be another question. I don't think we do. Okay, so there we go. Oh, we do. Test diffuse, right? Right there. So I don't know. Test diffuse might already kind of be what we want. We should totally see, because really that would be that kind of a blobby shape that I was talking about. So we'll see here. We'll see if make sphere diffuse map ends up being something that we want. In that case, we don't even need a test particle. We can just use test diffuse as our bitmap, and that should actually be fine, I think. We'll find out in a second, actually. All right. So I think we can do that. Although I also don't know, let's see, do we need anything else here? No, I don't think we do. So we can just go ahead and do it like that. Push bitmap, what do we need? We need render group, which we've got. Bitmap. Then we've got float to V2. Oh, that's a V2 My bad. We want our particles presumably to be fully 3D so that they can kind of go up in Z as well, since we do have Z stacks. So that's it for rendering the particles. Simulating the particles forward in time. We've got a position for the particle, right? And so this is going back to the equations of motion again. You know exactly the ones I'm talking about, which basically we could do a very simplified version here because we don't have an acceleration for the particle at the moment, so we don't have to account for acceleration. So all we have to do to simulate velocity is just say, well, whatever the velocity of the particle was, which we're saying we're going to track per particle, whatever the velocity was, we want to go ahead and take that velocity and update it by and multiply it by the time step. So however long it was supposed to be between last frame and this frame, it will move the particle by however much that was. And we do have dt up here somewhere, right there, input dt for frame, right? And so we can go ahead and just multiply out our particles, and that is pretty much the most basic, the simplest particle update loop. Now, at this point, our particles aren't even like placed in the world anywhere. They would literally just be always rendering like at the origin. You know what I mean? Which is kind of wonky. So we'll want to take care of that as well. But that in and of itself right there is the basics of a particle rendering loop. Now, at this point, we don't have any, reason to, we don't even emit the particles anywhere. We don't even really start the particles up. So all of their colors are going to be 0, 0, 0, 0. So presumably they won't draw, right? Although I guess I could go ahead and see what happens if I just force a color just so we can make sure that we're actually drawing something. But yeah, since they have no alpha, they won't draw. It doesn't look like I'm actually seeing any particles here though. So let me go ahead and step in here just so we can make sure that we're actually drawing things through our render group first. And also, since it's been a while since we've done this test diffuse, I want to make sure that that's actually valid as well. So we have a bunch of things here that I would like to go ahead and validate first. So I'm going to go ahead and break in there. Let me go to handmade.cpp and just take a look and make sure that everything's kosher. Although, the other thing I do actually also want to do is I need to make sure I set the render transform sanely for these guys, because we never, we set the render transform in here for all of our entities and stuff like that, and that's not something that I actually ever did. If you kind of look in here, we set the global alpha and we set some other stuff here, so we should probably make sure that we clean that stuff up first too. Let me go ahead and do that before we step in, just so I can know that we've set everything up, relatively sanely. Been a while since we did anything with the renderer, so sometimes it's a little bit crazy. All right, so I'm going to go in here and just make sure that we've set kind of all of the things that our renderer state might have, just so we can make sure that we're at a clean starting point before we start kind of playing around with it. And also, let me see about setting that render group transform as well, which of course requires me to page back into my brain how we ended up architecting our render for transforms. I might also want to stop the incessant piano music. We should probably have a kill switch for our music now that we implemented audio. We neglected to actually implement any way of making it stop. Which can be kind of tough. So we've got the render transform there, right? And if we look at that render transform, we're going to want that render transform to be controlled for the particle group. And so I want to take a look at the places where we set the transfer. You can see there's that offset P getting set to the ground entity point. I would like to make sure that we kind of clear that out for now, again, just so we're not looking at any kind of residual stuff from our old, from the code that rendered the entities. All right. So now what I'm going to do is I'm just going to step into that code, and I want to validate that we're doing things sanely there. Let's take a look here. So there we go. So each time through this loop, I'm going to take a look at the particles, and I'm expecting all of the values to be 0, right, which they all are, right? Everything's all zeros here, all zeros here. And then I'm going to take a look into when we do a push pip map here, and I just want to make sure that test diffuse is actually something that's validly drawable, because I don't actually know that it is. I guess, the other thing that I could do there, now that I think about it, maybe I'll just take that out of the equation entirely for the moment. Because what I realize is actually the other things I could do is I could just say, I'm going to draw a shadow, right? Because we know that works properly. I don't have to go back and look at the test diffuse stuff, which was kind of things we were only really doing for our lighting test. So there, that should definitely render something. And so if that doesn't, we've got kind of another positioning bug that we have to go address, right? So yeah, let's see. Yeah, so it should, I mean, that should be showing us something, and it's not. So I feel like I've got some little bug in there that I want to take care of. I can also make sure that it's very large so that there's no chance that it wouldn't be showing up, right? So we should be seeing something showing up there, right? So I think we've got, a problem with our render transform thing. So I'm going to go ahead and step in there because we should be able to draw something with that render group at that location and see like a little kind of blobby thing show up, if that makes any sense. So let's go ahead and take a look at what's happening with the push bitmap call. Obviously, it's going to get the bitmap from the asset system, which it does, and then it's going to go through here and try to put that bitmap onto the renderer stack. So let's see what the size ends up being for that guy. Here's the size that gets computed. After it seems like totally reasonable and sane. Then we go ahead and do some alignment on that guy, which puts us in, let's see where. That position even seems relatively sane. This, of course, is the part that I was a little bit confused about. I wasn't sure because it's been a long time since we did any rendering. We've been in kind of asset land for a little bit. And so when we do our transform here, right, what's the transform actually saying? It's doing standard perspective here, it looks like, right? Our orthographic flag is set to 0. We've got the offset P, which is going to be nothing. And I guess I don't know for sure that the offset P should in fact be nothing. That's, I guess, a good question. Well, then we've also got the scale, which is regular, which is the 1.0 scale. So that, that looks pretty sane to me. So I don't actually know why that is, is being grumpy with us, because it looks like that's a fairly sane thing. And I'll go ahead and double check. But it looks like that's a fairly sane thing to want to inspect, right? Of course, we've got that nasty problem of Visual Studio where it doesn't let us inspect anything when we step to the end of a function. All right, Visual Studio, how about if I jumped here? Could we inspect it then? Would you let us see it? Thank you. So that seems, assuming those are in pixels still, that all seems relatively sane to me. I don't know about you guys, but that seems fine to me. I don't know why that would be a problem, right? That looks like it's on screen, and well, I'll be honest, no, I guess it really doesn't seem like it's on screen. Because if that's centered, is that centered about 0, 0? Let's take a look at the drawing code for that. Maybe I'm actually wrong about that, because obviously we have a 1920 by 1080 screen, so I would like to just verify that that's in a sane location. I guess the other way to do that would be to sort of gang onto the hero, if that makes sense. So for example, if I wanted to, I could just go ahead and make sure that this guy was actually rendering all of the particles right where the hero is. So that would give me that extra level kind of assurance there, if you will. So let me take a look at that. So there's the hero. Okay, so I was wrong. I guess we were just off screen. 0, 0, 0 was not on the screen. Because you can see at the bottom of the hero now, there's like all these little, there's that really dark black dot. And that's exactly what we wanted to see. So all right, the next step here for doing our particle system is we're going to have to actually give these particles some color and give these particles some actual life to them, right? Because they're just sitting in one place right now, and that's like completely useless, right? So what we'd like to do is we would like to go ahead and actually start using the particle color, and we need some way of emitting the actual particles, like getting the particles themselves to sort of exist, for lack of a better term. And so what I'd like to do is I'd like to do something that spawns some particles every frame, right? So maybe what I'll do here is I'll just do like particle spawn index, right? And I'll do particle spawn index is less than, I don't know, 4. We'll spawn 4 particles a frame, something like that. And all I'm going to do here is I'm going to use basically a round robin scheme. I'm just going to take this value, right, that starts at 0, and I'm going to say game state next particle, right? So I'm going to say that the particle that we're going to spawn is just equal to whatever game state particles is plus whatever that next particle is. And then I'm going to advance next particle, right? Then I'm going to say if the next particle at that point went over the size of the array. So if it's gotten to the end of that game state array, then I'm just going to go back to the beginning, right? That's all I'm going to do. That's it, right? I'm going to say go back to 0. And so all I'm doing is I'm stepping through the particle array spawning particles, and when I get to the end, I go back to the beginning and overwrite. It's just like a circular buffer. I just keep overwriting older particles with newer particles, right? That's all it's going to do. So when I do this, I'm going to set the particle p, right? Whatever that particle p, I'm going to set that equal to, let's say, just 0, 0, 0 again for now, just back to the base. But this time I'm going to set that particle dp, right, the velocity of the particle, if you will. I'm going to set that velocity of the particle to go upwards, right, just z upwards, like so. And of course, I don't actually know if we really want to do that or y upwards, but I'm just going to let that do its thing at the moment, right? So let's go ahead and see here. Oh, and I forgot one more thing. We need to set the color to something, right? So we'll set the color right now to just be, yeah, I guess we'll just make it full bright for the moment. Okay, so let's see. We've got our guys. They don't seem to be moving upwards. I wonder if we need to, like I said, I don't really remember where we left it on our Z stuff. So yeah, so there we go. So now we've just got these little guys moving upwards, right? And when they can only go so far because at some point, right, the circular buffer will come around and kill them. I could spawn less particles per frame if I wanted to, and then they would get higher before being replaced, right? You can see. And there's no kind of variability in the particles yet, so they just kind of stack up there and just make like this very even cylinder, right? But even so, we're starting to get the hang of it, right? We're starting to see that there are some little particles here. What can we do next? I'd like to do a little bit something, you know, to kind of get that a little bit more like a particle system. So one thing that I'd like to do is I'd like to make our particles fade out over time, right? Like when they're spawned, I want them to be there, and then when they get to the end, I want them to kind of fade out, right? You know what we should also do? For the love of God, people, let us stop playing the music. Okay. No more music launch this time? Oh, that was just the loading call. My bad. Where is the call that actually plays this music? We got the volume change. Who actually plays? Oh, so you know what we could do? We could just make this music be something that's going to end immediately, right? Or we could make it be something that's not there or something like that. I don't know. What can we do? Because if we don't, I guess we have to make a thing that just the change volume call can handle a null pointer. That doesn't seem actually particularly bad, right? So we could do that. We could just make it so that Handmade Audio, if we just wanted to, give ourselves the ability to turn off that music, which I really do. We could just say that sound can be a null. You can pass a null and it's fine, right? It'll just deal with it. Not really a big deal. Extra ifs in there is not going to kill anyone, to say the least. So let's just get that music out of the way. All right. So what I'd like to do now is I'd like to fade those out over time. And maybe this would be a good place to use our kind of code editing, our live code editing, just so you can kind of see what happens as I edit this stuff, right? So you can kind of see the results as it goes, right? So let's maybe set up the screen, something like this, where we've kind of got just the hero part over here, and then I can use almost all the screen at that point for editing still, right? And we can just do it that way. That seems pretty reasonable. So all right, let's go down there to our particle system. What I'd like to do now is fade them out over time. So when I spawn a particle, I give it a color here. And basically what I want to do is I want to say, oh, you know, the particle P stuff, let's pretend that our colors had a velocity as well, right? So I want to do the same exact thing to colors as I did to my velocity, right? To my position, right? So each particle is going to have a decolor value as well. So that way, over time, I can set my particles to have some kind of a negative effect on, say, their alpha. So their alpha over 1 second will fade out to nothing, right? Because I have a negative alpha velocity on the color. So again, this is just like treating colors as if they were physical quantities that move through space, just like positions. Nothing fancy going on here. Red, green, blue, alpha, right? In this vector. And so I'm just setting the velocity to -1 on there. Now, I don't know if we clamp colors in the renderer. I don't think we do. So we may have to do clamping on that in the particle itself. But for now, we should be fine for that. So I'm going to go ahead and rebuild this guy here. And let's go ahead and rerun that. All right. OK. So now you can, and in fact, there you go. You can see exactly what I was talking about with the non-clamping, right? That's probably something we should just do in the renderer, because it'd probably be pretty free for us to just clamp in the renderer. So I don't know, but you know, I'm gonna put a to do in there basically and say to do Casey, shouldn't we just clamp colors in the renderer? You know, and I don't know, maybe we shouldn't. I don't know. We'll think about that. But anyway, what we can do here is we can say if particle color you know is less 0. Actually, I guess we could do. We even have a real. We even have our handmade math. I think we even have a clamp, right? So there's our clamp right there, clamp 0, 1. We can just go ahead and do that. So we can basically say particle color 0, or I guess we could say color R equals clamp, like so. Right, so I'm just going to clamp the 4, and that's not particularly efficient, obviously, but that's, you know, we'll kind of look at the efficiency concerns of this later. So there we go. And now we can see it working a little more properly. Maybe that was a little too aggressive. Maybe we want it to be a little slower on the fade out. And so there you go. But now you can kind of see that those particles spawn at the hero's feet, right? And they go up, you know, towards the end, towards his head, and they fade out into nothingness before they are ever replaced. So you almost can't even tell that we're using a circular kind of buffer for that. The other thing that I might want to do is kind of puff these particles up a bit, because remember, the shadow is kind of weirdly shaped in that way. And so I almost want to, yeah, I'd like to get that. Maybe it's a good time to use that test diffuse shape. We can see if that's actually useful. I don't know if it is or not, but we could try. And at the very least, we could make one, I guess. So we could do game state test diffuse, like so. That's got to be an address of probably, huh? I don't see anything, so that's not good. So maybe that's not the right thing for us. We might have to make our own particle. So I'll leave it at shadow for now. There we go. But maybe I'll have to add some particle sprites to the asset library. So we'll leave it at shadow for now, and we'll just live with that for a little bit while we do some sort of playing around here, right? So the other thing we can do is we can make, we can make this value above 1, so it takes, so the thing is darker for longer and doesn't start fading out till like a further part down. Although actually, now I think about it, this is kind of slightly wrong. Instead of clamping the actual color value, what I should do is make a new color value, because that won't allow us to set color values above 1 and track them, because it will immediately clamp it down to 1.0. So yeah, I set it to 2 here, but then it will immediately clamp it to 1. So what we really want to do is just clamp the output color, right? And so what I'd rather do is introduce like a synthetic variable here that's only used for the render path. We clamp that and pass that, right? And then we can do that sort of thickening, and then you can kind of see how that works there, right? And of course, we'd have to, we'd kind of have to fade it out, I suppose, a little bit quicker than that in order to not run out of rope there. But there you can see now there's like a while where it's full brightness and then it starts fading out. So we can actually do things that don't kind of linearly fade out over time. They can have kind of like a delay until they start fading out, even with just a very simple 2-parameter scheme where we've got a color and a decolor, right? So that's the basic idea of particle systems, right? So now we just got to get some chaos in there. We've got to get some motion in there, because really that's the majority of sort of the basic, your very basic vanilla workhorse particle system is already what we wrote. There's not a whole lot more to it. You can go kind of infinitely far with these things, but what we'd like to do now is start to put some randomness in there, because only once we get some randomness will this actually start to be kind of useful to us, and you can start to see how it takes shape. Of course, we kind of also need a good particle sprite, but that's something we'll take a look at in a second. All right, so how do we get some randomness in there? We need to go back and sort of get our random stuff going here. I think we still have a series. Do we have a series that gets initialized? I don't know if we actually have a series that we actually use for anything in particular. Let's see here, random bilateral. So I don't even know, it doesn't look like we have just a running series. So I'm going to introduce one because I'm going to want this, right? So I'm going to want a random series that's just a source of entropy that we can basically use. That random series is going to be, for our effects, right? Effects series. And the reason that I do that is because I want to separate things like particle systems out in terms of entropy, because remember, the random number generation for a particle system doesn't have to be particularly good. It can have all kinds of weird bugs and biases in it. Because it's not doing anything like generating the actual game map or something where we wouldn't want it to generate the same thing every time or do weird stuff like this. But the effects can be much more loose. So I'm going to break that out just so we always kind of know what's using entropy that we care about and what's using entropy that we don't care about, in case in the future we want to do different random number generators that are better or worse for different things, right? Although I have a feeling that a permuted congruential generator is going to be awesome either way, but yeah, we don't know yet. So better to split it out now when we can keep track of it easily than not, I would say. All right, so when we go and initialize the game state, right? And there we even have general entropy. So I guess we did actually have one right there. So what I want to do is maybe put that up here and call this effects entropy. So there we go. So I don't actually know what general entropy was being used for. Let's take a look. Play sound. So maybe general entropy really was that. Looks like that kind of was what that was. So maybe I don't even need this. But that's kind of not the best name. I guess I would just say effects entropy is a little clearer than that. I feel like that's, and maybe I'll even put a note there. This is entropy that doesn't affect the gameplay, right? So that's what I'd like to do. Okay. So effects entropy, that's our name for that now, effects entropy. Let's go ahead and change the name of that anywhere that it was getting used. I don't like the fact that we've been squeezed into this little corner here, effects entropy. There we go. So there we go. And this guy's still working just fine over here. So let's go ahead and now actually start using that effects entropy, right? Because we can do random between. We can use all of our calls that we were using now to actually sort of create some chaos in our particle system, a little bit of interesting motion, if you will, in that system. So I'm going to go down to the particle system when we spawn it, and now all I'm going to do, just very, very straightforward stuff, right? Nothing fancy. I'm just going to give it a little bit of x velocity by I'm just pasting in a little, that random between. Going to use the game state effects entropy. Right? And I'm going to say that I just want to do something between, -1 and 1, right? Something like that, right? And so now you can kind of see already, and I'll move that over a little bit so we can just keep watching it as I play with it, right? You can kind of see already that just by giving that, making that velocity kind of spread out, you're already starting to see something that kind of looks like a particle system. It's not a good effect. We have not done a very good job with that, but of course, like I said, we kind of need a better sprite for it if we're ever going to make something better with it anyway. But you can sort of start to see already, just with that very simple, nothing fancy, just very simple, we've already kind of gotten to the point where you can see, oh yeah, right, I get it, particle system, that makes sense, right? And so maybe that's a little bit, that spread is a little bit wide. It doesn't really make a lot of sense. So let's maybe narrow that down a little bit, right? It's kind of like Pigpen. He's kind of like a stinky hero at this point, right? It's what I'm reading out of that. And maybe I want to do the same thing with the spawn, right? Maybe I want to make the spawn a little bit wider, maybe not quite that wide, but I want to kind of spawn some kind of magical effect off of his sort of ground layer there, and you can kind of see that rising up like it does. And you usually want to put a lot of randomness into these particle systems, so we probably also want to randomize that sort of upward velocity, even though all the particles are going to go upwards and none of them go downwards. If we just change that sort of if we just give it a little more variability in how fast it rises, you can also see that it kind of adds more character to the effect. If we just give it a little more, it gives it a little more depth, it gives it just a little more interest if you do that, right? And And it's also, it's interesting to me. I guess we decided to just stop using the Z from these offsets. It's interesting to me that that just doesn't actually go up. But that's renderers. They're always complicated. Anyway, so that's the basic idea behind particle systems. Let's keep going with a little bit there. What we could also do is maybe it's just a little too boring to be using this particular sprite. So the other thing that I guess we could do, we could say that we wanted, I don't know, heads, right? And we want to kind of just spray little heads out because, I mean, who doesn't want to, right? And they've got an offset, so you can see they're offset from the ground because their sprite has that hot spot there. There's a torso spray, right? A torso spray is always pretty good. And you know what? How about a quick second for how awesome our renderer is? It's not even batting an eyelash, right? It's just like, whatever. You can spray as many torsos as you want at me. I don't care, right? So that's pretty cool. Anyway, let me put that guy back where he was. So we can spray something else there. And the reason that I wanted to spray something else there, whether it's heads or anything else, is because another thing that we might want to do, right, is we might want to give these guys some randomization in their color as well, right? Because, again, the more entropy that you can pack in there, the more interesting the effects typically tend to become, right? And so what I'll do here is I'll kind of just give it a little bit of entropy there in the RGB, right? And so we'll do a random that will sort of give it just a very little bit of kind of color variance in there, so you can kind of see just what that looks like, right? And so can you see how that's kind of doing? It's a little bit of a just giving a little bit of color to the effect, right? So the other thing that we could do there is we can make the alpha be a little bit variant as well, and we can make the alpha lower in general too. The other thing we could do is something like this, right? So now we're starting to get more of that kind of cloudy effect going. You'll notice, however, there's another problem that we're seeing, which is when we do something that's obvious like the head like that, you can very obviously see the particles come into existence, and that's something that we'll want to address too. I don't know if, it's 6:01. We've got 15 minutes left, probably. I don't know. I started it pretty late. I started at least 10 minutes late today. So we could address that as well. But let me just keep talking a little bit more about this before we do that. So what I'm going to do here is I'm going to try actually just beefing our particle count up a bit so we can play with it a little bit more. Let's go ahead and go up to 256 particles, about 4 times the number of particles that we were using before. Let's go ahead and just put that over there while we look at it, right? So there's our particles going, and I'm going to go over here to our particle spawn, and I'm going to say, all right, let's make them last a little longer again. Just get kind of a bigger oops, that's the wrong direction if you want them to last longer there, Case. So let's make them last a little longer again. There you go with that. And so you can kind of see, and I can also spawn them a little more densely, right? And you can sort of start to see, if you do lots of little things blended together, you can sort of start to see how it forms an amorphous mass. Obviously, you don't want to do it with the head of a guy because that's not going to look like anything reasonable. But you can sort of start to see what I'm talking about in terms of getting that sort of really odd amorphous kind of shape stuff going on. And I feel like what I really need, though, is I need these to back off a bit on their opacity, right? I need these to be kind of much lower opacity. Oh, wait, that's the D color. I need these to be lower opacity there. So there we go. Let's make that even lower. There we go. And so you can sort of see how it starts to do things that are kind of cloud-like. And again, we're only just doing the most basic of particle systems here because I just wanted to kind of get you warmed up. But you can see, you can kind of see how this sort of thing starts to go. Now, the other thing you can do is you can give particles an acceleration as well. And of course, that's if you want to do things that kind of can do gravity-like things, and we can do all kinds of things like field effectors and all that sort of stuff. But we'll look at those maybe a little bit more down the line. That's more something that I'll put in the game code, but I just kind of wanted to get some particle systems in here so we could start talking about them. The thing that I was going to say is, one thing that we do probably want to take a look at is the fact that this as a system where you just have D color oftentimes is not exactly what you want. decolor is often not expressive enough for the coloring variation. And usually what you want to do with a particle system is you want to have a very explicit way of kind of doing a color ramp through a series of colors so that you can start off at alpha 0, ramp quickly into a full alpha, and then ramp back out again, and so that you don't see that kind of popping down at the bottom, right? You want these particles to kind of fade into existence, and so you need some way of making that work. And you know, there's ways that we can pretty trivially sort of hack that in, right? Like there's ways we can could hack that in even with just what we had now. And basically what they would be is, instead of treating that color value, that alpha value, as a straight color value, we could just choose to put it on a curve, right? And we've talked about these curves a bunch, but I don't know if we've ever actually made a quick curve function. I don't think we have. And so that might be something that maybe this is what I'll start with tomorrow, because I don't really want to start it tonight. I won't have time to fully explain the curve stuff to you. So yeah. Yeah. I mean, to give you an example, this is not how I would normally do it, but just to give you a quick example of something that I don't have to explain the curve for, but that would allow you to kind of see what I mean by that, would be if we were, for example, to make the alpha value, say something like if color dot A, you know, is gosh, I don't know how I want to say this. So what we could do is say, all right, let's start the color values at 1.0, right? And let's, you know, we'll go ahead and do whatever the necessary thing would be to, to make that happen and fade out at a reasonable rate, right? That's just the weirdest darn thing. Yeah, okay. Well, you know, that's just, sometimes you got a bunch of heads spraying out of you. That's how it goes. So, you know, I've got something like this, and, you know, maybe this is roughly what I'm trying to do with the effect, but I want to get rid of, you know, I want to make that ramping, that bottom part not so noticeable like that, right? So, you know, again, I'm going to show you how to do some more advanced stuff with that, and maybe tomorrow. But for right now, we'll just say, okay, if the color alpha, you know, is greater than 9.9f, right? What I'm going to do instead is I'm going to treat the range of 0.9f to 0.1f. I'm going to treat that range as actually ramping back out, right? So what I'm going to do is I say, okay, the color A actually equals 1.0 minus the color A at that point. So, you know, it'll it'll basically say, you know, take that little range between 0.9f and 1.0f, which is 0.1f worth, and I want to subtract it out. So now I need to blow this color A, which is, you know, going to be 0.9 to 0.1. You know what? Why am I even saying this? We already covered this whole thing. We even made an entire thing for this, right? Clamp 01 map to range was actually the function that does exactly this, right? It's a thing that takes a range of values and produces the t-value that goes from 0 to 1 that fits the range. So we already covered this on a previous Handmade Hero. I don't have to say it again. It's your job to go back and re-watch it. All right, so I'm going to go ahead and map that 0.9 to 1.0 range. I'm going to map that in to make it so it's the full range from 0 to 1, right? Like so. And then what I'm going to do is say, well, okay, and I guess we could even do this range backwards. I think that works just fine, or should work just fine. Although, well, it does a clamp 0.1. Yeah, it should work just fine. So I should be able to do that. So it goes from 1.0 down to 0.9. So what I'm going to do there is I'm going to make that be the new metric for alpha. And so what I want to do is say, when it gets to its maximum height, when it gets to 1.0, it's going to be at 0.9. And then that way, as it continues down, it should be continuous, right? And so there you can see what that does. It starts those guys out at very dim and ramps them in so that you don't see that noticeable popping, and it just kind of looks a little more sane in there, right? So that's just a really simple way to kind of keep that from happening. All right, so what I think I will do now that we have done our particle system, our basic particle system, is I would like to do the Q&A. Someone was saying that if I just deleted my hex chat log, that this would all work. So I will see if that is true, because like I said earlier, it was not actually working, which is unfortunate. So let's take a look if that is actually true. Let's see, rem, and now I will try to delete logs, and yeah, so I will just delete those logs. I guess I will just, in fact, you know what I'll do? I'll just move the whole log directory to home. There we go. Xchat log, Twitch, old. There we go. And now I'll see if I can run my hex chat, because if I can run my hex chat, that would be pretty great, because then I could use the question prompter. Oh, no, it seems to still be crashy, but it still had the log. So how is it getting that log? I don't know. Maybe I'll move the whole logs door, kc.config hexchat logs, to home kc.config hexchat old logs. Does that help you, Handmade hexchat? It's still getting the old chat somehow. I do not understand how. Yeah, that's kind of weird. ls home kc.config hexchat. Why, oh why? Or, oh, maybe it's the scroll back. That's what it probably is, huh? It's probably the scroll back. So let's just do that. Let's just do a rem -r on that. So I don't even want the scroll back. One more time. Oh yeah. All right. Let's see if the scroll back works. It does. Okay. Hey, thanks to everyone who told me that that was the problem. Now that's good. We can actually do our Q&A with the standard Handmade Hero. So there we go. All right, everyone. Now is the time for questions and answers. If you have a question about particle systems that would like to ask, please go ahead and put Q: in front of it so that it will come up on my little question prompter, which thankfully I was able to actually get working thanks to people who said that it was the fact that hexchat was messed up. Jonathan Blow, in fact, has joined us, and he says, for a while I have felt that interpolating particles in RGB leads to results that are dull and muddy. I have been wanting to try YCRCB and maybe even LAB sometime. I guess you can compensate via splines through RGB, but I think you'd be doing a lot of tweaky work all the time to get better results, even though YCRCB is just a linear transformation. I think there's a substantial amount of skew. So what I would say is I actually have used HSV before, even, and it's actually not that expensive to do HSV transforms, especially not if you're already on hardware and using a pixel shader, or in our case on SSE. It's actually not that many instructions to switch from HSV over. And I've done HSV particles before, and it is pretty darn cool. It's like really easy to make rainbow effects and stuff like that. So I have not tried YCRCB myself or any of the other XYZ color space. I haven't tried any of those kinds of things, but I can say from experience that HSV particles are a good way to go. I don't know if Handmade Hero will need that, but it might be fun to do an optimized HSV transform. And so maybe we should just do it that way. Because yeah, I would agree. I don't really like RGB particles that much, although they're certainly the most expedient kind. And since particle systems are usually a speed thing, sometimes that's a good thing. But I would agree with that. Rohit N, not sure I missed it, but will particle pre-warming be supported? So I guess I don't really know what we'll be doing in terms of pre-warming. What the person is asking about is the fact that particle systems take a while to evolve to their natural state. Like, for example, right now you can see that this is what this particle thing should normally look like. But when I start up the game fresh, right, it doesn't look like that. It takes a while for the heads to get, to fill out and be in the state that they're supposed to be at. And so if for an effect, that doesn't matter because the effect is something that happens and then the particles spew out, right? But for something that's kind of a continuously rolling effect, the classic example is like a waterfall. You don't want your game to be in a state where the first time you start seeing the waterfall, there's no water on it and the particles start at the top coming down and then eventually it looks right. You don't want that. So how we would actually deal with that is a good question. I would rather hold that off till we actually find out if we have that problem on Handmade Hero. But because there's a lot of different ways we could choose to address it, and it's probably going to depend on what kind of particle systems are having that particular problem, how we would choose to address it if it was a problem. When you were messing with the Z direction, it seems like kind of a puddle on the ground. Yeah, when you don't have any Y motion, it did seem a little puddle-like. Ever messed with using some kind of stateless system for doing this, like one function parameterized by another function, if that makes any sense? Yes, I have done that before. I don't love it. It's not really my favorite thing. I find that it limits the particles too much. And a lot of the things that you want to do with particles that are cool don't really lend themselves to that kind of parameterization unless it's incredibly slow, because it's just such a huge set of things it has to do. Is rain a particle system? Yeah. Oftentimes rain would be implemented as a particle system. I wonder if head particles like this could be used in the game, for example, as an effect of magic related to disguises, like when you dissolve the disguise of the superfish. Sure. I mean, who knows, right? Never say never. Witness is RGB and probably too late to change, but we don't rely on wowie particles much. Yeah, I don't know that the witness would really need it. I mean, maybe there's a couple of places it could be cool. I don't know. I definitely wasn't walking around the witness going, oh man, the particles in this game really need to be HSV'd. So I doubt that it's something that would really, it's not the kind of a game that has a lot of, as you described them, wowie particles. But yeah, I mean, there are some places where maybe it would be fun. I don't know. But yeah, like the HSV thing is only a limited degree of, I mean, you know, it's very specifically for doing rainbowy kinds of effects, because if you're not moving through color or saturation space as a thing, then, you know, it doesn't help you at all. So it's like you have to actually have something in mind where you're going to want color variance, like more than this kind of color variance, right? Z still points toward the screen, I think. Yeah, I think you're right. I don't know, like we kind of still, our last pass on the renderer that's still up there on the to-do list has got to be going through and getting the whole layer thing, because we're still in weird town with our going in and out, where it looks correct, but we don't have any, we don't have the floor layers stacked up right and stuff, and so we have to go in and kind of finally get all that stuff laid down, right? Nucles! Does anyone ever use layers or just Z sorting? Layers. I'm not sure what you mean by layers. What times does Handmade Hero stream? Saw this on the front page and it seems interesting. You can go to handmadehero.org actually, and if you go to handmadehero.org, first of all, there's a live button. You can always see it counts down to the next live stream. So you can always look at that. But then we also have a tweet bot. So if you go to the tweet bot, it's always got the schedule. It's got your back. It tweets the schedule, and then it tweets the video from as soon as it's up from the previous show in case you missed it. So the tweet bot is your friend. If you're trying to catch the stream live or catch up with the stream, the tweet bot is definitely your friend. Jonathan Blow. Maybe for the Galaga game, I will switch to HSV. Dude, I don't want to hear about the Galaga game again until you add a bonus round. Okay? Where is the bonus round? Everyone knows that Galaga is all about A, fighter capture, and B, the bonus round. And you were like all about denying me the bonus round. I don't even know if I want to play this Galaga game at this point. Because if there's no bonus round in a Galaga game, why is it even a Galaga game? At that point, it's like Space Invaders or something. I just tuned in. Will these videos help someone learn C and C++ who has absolutely no experience? Sadly not. That is a project that I would really like to do at some point, but I had to start somewhere. And so I decided that making a game for people who already had some programming experience was the best place to start. If you do go to Handmade Hero, if you go to handmadehero.org and you go to our video archive, there actually was, if you go to playlists, a test stream I did down here called Intro to C on Windows. And you can go to there and you can look at a little just test course I did to show people a little bit of how C programming works, but it's not enough, right? And so, yeah, someday I would really like to expand on that, and it's definitely a plan, but I just don't have time to do that right now. And so my goal is to make a companion to Handmade Hero in the future that's like, here's how to, if you know nothing about programming at all and you someday want to do the Handmade Hero course, here's the thing that will take you from knowing nothing, like I don't even know how to program, turn on a computer or something, all the way up to like I can program in C, okay. Because this doesn't actually take that long, but it is much more involved certainly than 5 episodes of a 1-hour show. Okay. Is that it for questions? Looks like it is. Everyone's good on particle systems, I take it? Everyone's good on how to make heads kind of spew out of your belly? This kind of looks like that's happening there. Which I guess is a little bit. Let's see. Have you or will you explain how shaders work eventually? Well, we wrote our own renderer, so we wrote shaders. Like, we actually wrote the part of the code that is the shader. So we already did that, actually. But if you're just asking, like, how do I write an OpenGL shader, like the syntax of the language or something, no, we have not covered that. And we probably will cover it lightly when we port this thing to OpenGL or, Vulkan or something way down the line. Will these particles be able to react to things like impacts? Yeah, I mean, that's exactly, the sort of thing that, that's exactly the sort of reason why I said I don't like to make particles be functions, be closed form functions. Someone was asking about doing that, because I like to have the particles, if they're all just there, and being simulated like regular physics kinds of objects, you can choose to spend a little more CPU, not much, just a little more CPU, to have them do stuff like react to explosions or wind or stuff like that that's variable through the game, and not have to worry about how to constantly fit that into some crazy closed form way, right? How many particles? That's 256 particles at the moment. That's kind of spewing out there. How many until we see a noticeable slow downage? Well, so I don't know, because we haven't. There's different timing things here. There's a couple different things. This is not a very good way to process the rendering. First of all, calling push bitmap for every particle is not really what you want. So what we would probably do when we get to, instead of playing around with particles, when we're like, okay, we want to do a high-end, particle thing here, we would do more efficient throughput than this. But right now, I'm guessing that it's actually the scaling, it's actually the rendering of the heads that's going to take the most time. And since that's the case, it's going to mostly be about how big the particles are, as well as how many there are, not just how many, but how big. So I suspect that I could slow this down. I could put a lot more strain on the renderer by making the heads much bigger, right, than they are, right? So you can kind of see that starting to slow down already, right? Because now there's just a ton of overdraw. It's having to overdraw that like really ridiculously much, right? And so, again, that's something that's like, I don't know that we're going to try. We're not going to kill ourselves to make to have tons of particles on the screen on the software renderer. I'm fine with it being the case that that maybe we don't actually do our particle systems in the software renderer. We only do those on the hardware. But even that said, there is kind of a way that we can do particle systems pretty fast in software, and so we might just for fun show a little bit about that, because there's some interesting things we can do that would allow us to scale to very high particle rates in software, and maybe that's a fun thing for us to play around with, just because hey, it's an educational stream. It's not always about doing the most expedient. Sometimes it's about doing something that's just kind of cool, right? Are you using Emacs outside of Visual Studio or inside of it? Outside of Visual Studio. When do you plan on implementing a way to adjust the position of the individual particles when the entities move? Well, you don't really have to do that, right? I just kind of stuck it in here because I didn't want to deal with it, but you can just put it outside, right? So, you know, a lot of that is just figuring out the placement. You know, one of the problems with the particle systems is we have to figure out how we want them anchored, right? And so, you know, I'm not sure what the right way to do that is, but we presumably want to anchor them in the world, and I don't know, maybe also have some that are kind of screen spacey. So it's hard to say. What made you pick C++ over C#? Well, C# is not really a language for programming computers, right? C# is a language for programming other programs. It runs on top of a virtual machine, and it has like garbage collection and all of this other stuff. So the point of this project is to show how to actually program a computer. So I wanted a language where you wrote code that is directly translated into assembly so that you could see, you know, that kind of direct correlation between what you're doing and what the computer's doing, as opposed to C#, which is more about telling Microsoft's code how to do what it is you... It's more about telling Microsoft's code what you wanted it to tell the CPU to do, which is not at all what we're trying to do on this stream. What parameters will you tweak with curves? Scale, position, color, rotation, external force, etc. And will the curves depend on time only? Maybe this question is for tomorrow, though. Well, I don't know. Like I said, you know, particle systems tend to be very ad hoc. You know, I mean, unless you're sitting down to write like a licensed engine particle system, like, you know, if you're Epic or, you know, you're Unity or somebody, right? And you have to ship a particle system that's like this general particle system that's designed to be used by like all the games ever or whatever. You gotta think through like how you're gonna support all these crazy diverse cases, and you can't support them all perfectly, so you do some kind of like thing that maybe works for most of them and whatever, right? We don't really have that problem because we're hand writing our games, so we can just, as we come to things that we need, we can do whatever makes the most sense for that, right? So we don't really need to think about that. We can just go, okay, I showed, we took today and we'll maybe take tomorrow to just play with particle systems, so now everyone knows what they are. We'll put them on a shelf for a while, and then when the game is up and running and we're mostly doing game code, then we can just go, hey, you know what, it'd be nice to have some particle effects in here, and then we can write the particle code for that particular circumstance as it arises, right? How many times have you said write in this progress? I say write a lot. The other one I say a lot is basically. So I would not try to count those two. You're going to get to very high numbers. You're going to overflow your counter. Vertical flow now. How about to show how to fix horizontal? I don't know what that means. Nucles, is your Emacs config open source? It's not open source, but it is included if you pre-order the game. It comes with the source code, so it's in some sense. Can you explain what procedural level generation is, and are there other types of generation, and if so, what is the difference? Well, procedural level generation is usually the phrase that's used to distinguish games that generate their levels fresh every time using algorithms versus games where there were level designers who made the levels by hand and positioned the things where they're going to be. So it's like procedural level generation is just the blanket term for this game has actual code that runs when you start the game to figure out what the levels will look like so that they can be different every time instead of always having to be whatever a level designer sort of laid out, if that makes sense. Gary Johansson, off topic, what do you think about using Unity as a platform layer and using all your own logic? I've never really looked at doing something like that, so I don't have much of an opinion about it, other than to say, I don't like C#. I wouldn't ever program in C#, and Unity is kind of about enabling C# as the logic layer. So I feel like that would be kind of an automatic no for me. But, that's not an informed opinion. That's just my, immediate thought. I write my own engines from scratch, so obviously I don't ever need to ask that particular question. So I'm never going to go look at Unity to see what I think about thing X, because I, know a priori that I'm going to be happier with my own code. So I always use my own code. Why do you pronounce nightmare as nightmare? I didn't know that I did. Do you have someone making the game assets for you, or are they shelf-made? Yes, Yangshin Lee is making the art assets, and she is a very good painter, and she makes the art assets for this game. Will you be making development tools for Handmade Hero like a map editor? No, because it is procedurally generated. So there is no map editor. The maps are created by the game, and they're different every time. I mean, is your config public domain? Can I give it to someone who'd like to get started with Emacs? I myself pre-ordered ages ago. Best $15 expenditure of my life, no contest. For you, Nukels, of course you can. You can use DLLs. I have done this much using Rust, FYI. So you're kind of saying, just to patch it back to the previous question, you're saying, using Unity as a platform layer, but driving it with compiled DLLs. I guess what I don't super understand there is, how do you run the DLLs on the other platforms? So like, you can't load a DLL that you compile on Windows on Android, right? So I guess I don't understand what you mean by platform layer if you're saying DLL, because DLL is Windows and sometimes Mac, but that's more or less it. And so I'm not sure I understand what you're advocating at that point if you're saying DLLs, linking DLLs to Unity. Because what do you mean by platform layer at that point? It's not really a platform layer unless you can run it on all the different, well, platforms, right? Noogles, I don't know how to pronounce your name. I have no idea how to pronounce your name. I feel like if you want your name to be pronounced properly, you have to put a little pronunciation guide next, because Kknewkles is really hard to guess. I was saying Knuckles before. Now I'm saying Nukels, but you're saying maybe it's Knuckles? I don't know how to say it. I do not know. Henko7, I mean the particular flow or direction is now from bottom up. Feels like it's not hard to do left to right, for example. You mean are you just talking about, I'm not sure what you're talking about still. Are you just talking about the fact that the particles go that way? Because yeah, sure, you can make the particles go any way you want, because dp, the direction, right, the velocity vector, can point in any direction you want. I mean, here's the velocity vector written out explicitly, right? And if you wanted it to go in some other direction, you could totally do that trivially, right? You just say, oh, you know what? It's going to have a sideways motion to it as well, right? And now they spray off kind of in that direction or something, right? And you could obviously say, oh, you know what? I want to cut. You know, I want to keep it chaotic up and down, so it's kind of a spray out to the side, right? So yeah, all that stuff is really pretty straightforward, because you just have a velocity vector, and so this velocity vector is just whatever direction it points is the direction the particle will go, you know. So hopefully that answers that. Gnuckles. Gnuckles? Oh. K-Nuckles. K-Nuckles. Okay, so K-Nuckles is how you pronounce it. K-Nuckles. I like that other people are selecting like Chuck Norris. We could just call you Chuck Norris. K-Nuckles. All right. Well, I think we have come to the end of Handmade Hero for today. We are now spraying heads around, and let's be honest, that is always something that I feel like we want to be able to do. Who doesn't want to be able to spray a bunch of heads around? I feel like I speak for everyone when I say that that's something that everyone wants to do. So let's go ahead and close that up and get our dev studio closed down, save our, our mischief, and let us go back to the Handmade Hero webpage. Okay, everyone, thank you for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the series, you can always pre-order the game on handmadehero.org, and it comes with all the source code. So every night you can go ahead and play around with everything we're doing and experiment with it, do whatever you like. And that is updated every night, so after I'm done, I put it up there. We've also have a forum site. You can catch up on old episodes by taking a look at an annotated episode guide the community's done. You can get ports to Mac and Linux that members of the community have done. If you're trying to follow along on a different platform, you can check those out. They might help you. We also have a forums page where you can post questions, or if you have things that you want to ask about the series, that's a good place to do it. We have a Patreon page if you want to support the video series. It's always much appreciated. And we also have a tweet bot that tells you when the video series is live. So check those out if they sound interesting to you. Until then, I will be back here tomorrow. Same time, same place, 5 p.m. Pacific Daylight Time, right here on Twitch. So if you would like to play around with particle systems with me some more, that is when we will be doing that. Until then, I hope you have fun programming, and I will see you all on the internet. Take it easy, everybody.